For my Strive project, I created an interaction between two blocks, where the number of collisions ends up approximating pi. Hi, my name is Luke, and I'm an 8th grade student at the Singapore American School. In this project, I created two blocks, one big and one small. As the big block moves towards the small one, the collisions between the two blocks slowly causes the big block to switch directions. As this occurs, we count the total number of collisions that takes place. In this example, there are 3 collisions before the block changes direction. As we change the relative sizes of the blocks, the number of collisions changes. At first, this number isn't particularly interesting. However, as we increase the size by a factor of 10, the number of collisions miraculously starts to resemble a large multiple of pi. Getting the block collisions to work correctly was the first hurdle. In an idealized example like this, your calculations need to be extremely precise in order to properly conserve the energy of the system. A concept I learned was called an elastic collision. An elastic collision is one where there is no loss of energy during the collision. To do this, we use the coefficient -1 in the code. This means that after the collision, the direction of the block will be multiplied by -1. In other words, direction changes, but speeds stay the same magnitude. An inelastic collision, on the other hand, is one where there is loss of energy during the collision. To do this, we use the coefficient -0.3 in the code. This means that after the collision, the direction of the block will be multiplied by -0.3. In other words, direction changes and the speed reduces to 30% of what it was before the collision. Any coefficient between -1 and 0 will be inelastic. The surprise of seeing pi pop up here was off the charts. There is no reason to think that a circle has anything to do with the blocks colliding, and so seeing pi here was just incredible. It's also really cool to see how physics, mathematics, and code all come together in this project. The entire experience has made me realize just how much math is involved in computer games.
The fact that pi shows up here is insane. But what stands out to me the most about Luke's work is the clarity with which he explained the advanced concepts of elastic and inelastic collisions. Richard Feynman once famously said, "If you can't explain something in simple terms, you don't understand it." Well, for an 8th grader, this is something he clearly understands.
Will be multiplied by approximating pi. Pi.
Good. All right.
We use the
Try again.